Hi, so today I'll be explaining this question here using Euler's method. So sorry for my horrible voice since I'm sick right now, so bear with me. Okay, so Euler's method's general formula is this, which doesn't make sense at first glance, so we'll break it down. So on the right side is all the terms needed to know for the context of this formula. So n being the count, which is shown here, is basically the amount of times the process is happening. As you can see, count 0, starting from count 0 to count 1, 2, and 3. H being the step size, which is basically the value that gets added to the initial values of x and y, which will be explained further later on. Our given condition from the question earlier is y0 equals 1, basically meaning when x is 0, y equals 1. And we're trying to find if when x is 1, what is y? So that's what the Euler's method is for. And we have our given equation, which is x over y squared, which is what we'll use for our calculation in our y column. So basically, starting from the very first step, from the very first count, at count 0, x is 0 as given from here, the given condition when x is 0 and y equals 1, so meaning y should be 1. Now, our step size, assuming that is 0.1, I'll explain why I chose 0.1, is then added to x, because in the next count, step size will be added, which is then 0.1. However, for y is a special case, as there is a formula for y that requires to achieve its own value. So for y, it's a mixture of using previous values of x and y. For example, at count number 1, it's using the previous value of y, which is 1, plus the step size, which is given here, multiplied by previous value of x, which is 0, and divided by the previous value of y, which is 1. But for this case, we're using the function that's given to us, which is this, x over y squared, which is then applied in this formula here, which in turn we would get 1. So this whole process repeats over and over again until the column x shows 1 and the y column will reveal our y value. As to why I chose the step size as 0.1 is because if I were to choose a higher step size such as 0.5, the count will only end after 2 counts, like as you can see here. So it will result in lesser accuracy. Okay, so right now, in a more practical sense, in Excel sheet, Euler's method can be implemented in Excel. So as seen here, my formula for the count is simple. Basically, adding 1, since the count is added by 1, to every single cell above it. So for example, count 1 is added by 1 to the next step to become 2, and so on. So it goes on and on and on until 10. For x value, since it's only added by 0.1, which is the step size, the formula is similar to the count, which is just being added by 0.1 up. So it goes on and on until it reaches 1. So for y here is different since I'm using a different method, which is the previous x and y values multiplying each other.